Hello everyone, and welcome to this session on connection design with RAM connection. I am Surajit Ghosh, and in this session, I'll cover how we can create a custom database in RAM with company-specific templates, update existing template from any standard database, and use those for connection design. During customization of connection database, we need to maintain correct database format. What is the correct format? How we can avoid any mistake during template generation? That I will discuss in detail. In the last part, we covered the details of template-based connection design in RAM connection. We used couple of standard BCF templates from AISC database, including a single plate or side plate connection. For these standard templates, all connected information are predefined. Plate thickness, bolt size or grade, position of plate or hole size, everything is fixed. And these are used during connection design. After design, we can modify any data based on the design results. This process is not suitable if we want to use some custom data during design, like a specific bolt dia or grade, custom plate thickness. Also, it's very hard and time consuming to modify the same information for 100 such connections. In such case, best option is to create a custom template with user-defined connection data and use that for design. We can create our own database with different configurations, and this can be achieved using an option, customization of connection database. If you look at this window of standalone version, you will notice that in RAM connection, there are different database available, like we have the standard section, material library, connection library, bolt and welding information, and anchor bolt library. These are my standard templates. Whenever we are opening this window, these sections are coming from my standard database. This is standard section library. And all these are my standard one. Say for section, I want to use a custom section. Here, ISMB 600 section is available. I want to use the built up section, built up I section with depth 1 meter. Or I have a built up section with a different type of top and bottom flange. Those are not available here. These are all my standard section. These are my standard material library. I want to use a steel section, material of which is not available here. I want to use a custom material. All this information, including our connection bolt, these are my standard bolt. For AISC code, these are my standard bolt. If I select Indian design code, these are my standard bolt. I don't want to use this one for my project. I have some customized bolt that is coming from my vendor, and I want to use that bolt only for connection. Everywhere, each and every item is customizable. It is not like that whatever standard is available, you need to use that one. You can customize every information which is used for your connection, whether it is section, material, connection, bolt, or anchor bolt, everything you can customize. First, I will start with connection, then I will move to section and then bolt. Rest of the things are not that much required, but the procedure is same. The most useful one is the connection library and the section library. I want to use a custom section and I want to use a custom connection. How we can do that one? If I click on this connection database, this MyBCF connection will open. This connection is my custom connection. I will talk about this later. Just look at this connection database. All these are my standard one. For United States, for India, Europe, all these are my standard connections. Then United States, I was talking about the single plate BCF connection. Single plate BCF, these are my connections. Now, these connections I don't want to use, and I want to use a connection different from the standard one. How I can add that connection and use for my connection design. For that, what you need to do is that add that connection. Here you can notice add a new group, add new sections, new table. All these informations are available, including you can edit the item. This standard one also you can edit. So for example, like this is my single plate BCF connection with half-inch thick plate and 2 number of bolt. If I want to edit this one, I can simply click on this one. I can edit all the information, but I do not recommend editing the standard template. It is not a good practice because whenever you are passing this connection design to your client, they are using the standard one. It might be a data mismatch because the name is same, the standard database is same. So it is not a good practice to edit the standard database. Rather, if you want to edit this one, it is better approach to copy this one item, add it to your custom database, and then edit that. Though the edit option is available here to edit any standard database item, still I'll not recommend to edit this item. Rather, if you want to edit this, there is an option to copy. You can copy this item and you can modify that one. That is a better approach. I'll show you all the process. I want to create a new database, add a new group under which I want to store all my custom database or custom templates. I can simply click on this briefcase like icon, provide a name, connection group 1, and this creates our blank database where we need to add the table. Now, you will notice that this CG1 is available under the list. This is my new category. Here, say I want to create a side plate connection, single plate connection with custom data. We can create a new table. Under this database, new table means this one. This is my tables. You can see the name here. So after we create the group, we need to create the table. Now I need to provide information about the connection. What type of connection it is? By default, it is always a frame connection. No other option is available. Design code we need to specify because the table and items are associated with a particular design code. So we first need to specify what design code it is. All design codes are available here. For this case, say it's a AISC template. Next is our connector type. What type of connection it is? It's a CR connection, moment connection, combined connection, cassette, tubular truss connection. Say this is my CR connection, side plate CR connection template. Similarly, we can also select a moment connection or CR and moment connection. Now, whatever connector type we are selecting, based on that, we have different type of connections. If I select this gusset connection, then the joint type will be changed to my gusset connection templates. If I select this CR connection, then this joint type will show what are the different type of CR connection. This joint type depends on my connector type. It's very common. Like if we select a CR connection and if we are looking for a gusset type of connection, like a cross pressing, vertical expressing or horizontal expressing, that is obviously not available under a CR connection because that is gusseted connection. We need to select the connector type as CR connection. We need to select the joint type. For this case, it is a beam column flange connection. I can select this beam column flange option from here. So we can select any type of connection as well. Beam column flange, beam column wave, beam gutter connection. Say this is a BCF connection. Next, what type of connector we are going to select? Under the beam column flange connection, we have different type of connection template like CR end plate, we have single plate connection, we have standard T type of connection. Different type of connection templates are there. So what type of connection it is? It might be a bent plate, single plate, through plate, or stiffened seated connection. Different connections are available, including the T bracket connection. For this case, I am going to select a CR tab connection or single plate connection. So these are the information that I have provided. Relevant picture is available here when we select the connector. What we selected here is the design code, connector type, shear connection or moment connection or cassette connection. Joint type, it's a beam column flange connection, beam column wave, beam gutter connection. And finally, the connector name, single plate, bent plate, through plate, T type of connection, what type of connection it is. These are all the information we need to provide. Now we need to provide a table name as well. Table name means this table name. These are the table name. This is called single plate V-shape connection. For my case, let's provide that as side plate shear BCF. This is my custom table name. This is same as this one. So this is my table name. Once I provide all this information, then we can click on OK. I have created this item. Next, I have to add this item one by one. Group, table, then this item. And this item creation entirely depends on my selection. If I create this table with a shear connection, BCF connection, I cannot expect to create a beam column wave type of item under this table. All the items will be linked to my shear connection, beam column flange, and it's a single plate connection. These items depends on this information. If I click on OK, now you'll notice that under this group CG1, I have a new table called side plate shear BCF connection that I have provided as the name. This is also customizable. Anyway, I'm not going to modify this name right now. Now comes the custom item. That is the most important one. That under this table, I want to create a new template which I am going to use for my connection design. How I can design a connection on basis of my custom connection information. Here you can notice you can rename the selected table. If you want, you can change it from here. You can delete that one. I'm not going to do that one. I have just created the table and I'm going to use it to add the item here. And next item is that new item. We can copy and paste any item from our standard database. Like I was talking about this one. If I want to edit this one, we can copy the item and paste it in this table. We cannot copy any item from beam column wave connection and paste it under a beam column flange connection. Not possible. We need to copy paste the data from same type of connections. We can copy paste the data or we can create a new item. For this case, I'm going to create a new item. Click on this new item and it will open this connection design interface. Now, here you can notice several informations are available about this window. What are the informations that we need to provide? First information that we need to provide is a connection name. And then there is an option called optimizable. I am going to specify both of these latter. First, let me modify the connection information. In this connection pad, you will notice that there are some blue ticks. Blue tick means coming from my joint data. And this we don't need to modify here because this is a connection template and these sections are irrelevant for this. Sections are just for representation. Whenever we are going to assign this connection template to any joint, section information will come from there. Here you can see the beam section is an Australian section. I don't need to change this one. I am not going to use this Australian section for my connection. The section will come from the user input, from the joint data. So I don't need to modify this information. This we can modify during our connection design. For custom template, only important point is this connector information. Rest of the things, we don't need to change it from here. We are going to use a ISMB section or we are going to use the AISCW sections. So those information will come from the user defined joint information. I need to only provide information related to my connection or connector. Say what I am going to do here is that I am going to use a quarter-inch thick plate, 1/4. I'm going to use a material that is coming from my US database, A36. We can provide any material from here. Plate position on beam, whether it is on center, top, or bottom, that we can select. Let it be at the center of the beam web. We can also move it in the upward direction or bottom direction. Next is our bolt information. What is the bolt that we want to use? It is selected from the Australian category. I am not going to use that one. Rather, I am going to use the US database. These are my standard bolt. If I want to use a custom bolt, we can customize the bolt library as well. I don't have any custom library available, and I'm going to use a bolt which comes from my standard database. So different standard bolts are available here. If you want to use a custom bolt, simply you need to create a custom library, select that library from the group. It will be available here, and then you can select the custom bolt. For now, I'm not going to use a custom bolt. Rather, I'm going to use a standard bolt. Say this one, 1-inch thick A325N grade of bolt. I have selected this one, and you will notice that this bolt is changed. Do not consider this class detection and everything here because the sections are not here. This is just a representation, and we are just working with this connector only. This plate, this welding, this bolt, we are working on this one. These sections are just a representation. Number of bolt, 3 number of bolt I am going to use here. Now, there are different other information as well. Pitch, the horizontal edge distance, distance between the weld and bolt. I am not going to change anything. I'm going to use the standard one. You can change it as per your requirement. Final thing that I am going to change here is that I am going to use a slotted hole for the beam. There are two types of slotted hole available in RAM connection. One is called short slotted hole and another one is called long slotted hole. I am going to use the short slotted hole, and the slot direction we can also provide, whether it's the slot direction is in the horizontal direction or vertical direction. I am going to use the horizontal slotted hole. And finally, we have some information about the welding electrode. I am going to select the United States, say E70XX. This electrode I am going to use. The weld size I'm not going to change. Let it be 3. These are the custom section information that I am going to use for my connection design. So 1/4-inch thick plate, 836 grade of material. Plate position is at the center. This is my bolt. This is the number of bolt row. These are my edge distance and everything. I am using a slotted hole for the beam in the horizontal direction. This is my welding information. And using these informations, my connection design will be performed in RAM connection. Now what we can do? We need to provide a name here. Say this is my side plate connection for AISC code. Provide a name using which you can identify the information that is used in this connection. 1/4-inch plate, 14P for plate. The bolt is 1 inch. And then what other information? 3 number of bolt is used in a single row. 3 bolt in a single row, and it is a slotted hole. Slotted in horizontal direction. I have provided this name because it's easy to identify the connection. Single plate, AISC code is the design code, 1/4-inch thick plate, 1-inch bolt I have used. I can also provide this complete information, 1-inch A325N, but anyway, that's too long. So 1-inch dia bolt is used, 3 number of bolts are used in a single row, and it's a slotted hole in the horizontal direction. And if I select this optimizable option, program will convert this to a smart connection template. Means program will start with this information and try to optimize this connection. And this connection will only be available under your smart connection category. I don't want to do that one. I want this as a basic connection where program will design the connection on basis of this connection template information, and it is not going to perform the optimization. I'm not going to select this optimizable option. Optimizable option is useful when you want to start with a basic information and then you want to optimize the connection. If you select this option, then this template is available only under your smart connection template. You will not able to find this template under your basic connection. If you don't want to optimize this connection, do not tick this option. This means your connection is smart connection, optimizable. This means your connection is basic connection. So I want this to be a basic connection, not a smart connection. Simply save this template. Now, this custom information, on basis of this custom information, a template is created. The name of the template is this one. This is a basic connection template, and I am going to use this template for my connection design. This information coming from the join. So if I close this one, you will notice that this connection is now created. Under CG1 category, it's a side plate CR BCF connection, and this is the connection template. Side plate AISC, quarter-inch thick plate, 1-inch bolt, 3 number of bolt in a single row, and it's a slotted hole. Now I am going to use this connection for this joint. You have modified the database. Under this template, you will notice that there is a new category here. So these are the standard one, United States, and this is my custom one, CG1. And under this CG1, this table is there, this item is there, and I can assign this item to this joint. Say, assign template to this joint. Now you will notice a CR connection of this name that we have created right now is assigned to joint number 40. This is assigned. And I was talking about these sections. Whatever section is used there, that is not here. Because this beam information or this column information, it is coming from my user input. Whatever section I have assigned during definition of this section, it is coming from here only. That's why those section information during your connection template generation, that is not relevant because these are my user input. And now if I check the connection template, quarter-inch thick plate is used. A36 was the material grade we have used. Center, it is positioned at the center of the beam web. The bolt is 1-inch A325N bolt that we have selected. 3 number of bolt is used, 3 number of bolt in a single row. These are the pitch and everything. The hole type on beam is slotted hole in the horizontal direction that we have selected as the default option. This is my welding information. So these are all my custom information which are now used for connection design. This is the way we can customize a template and use that template for my connection design. And it is very useful when in your organization, you are using a custom template for your connection design. You don't need to modify all the connections again and again after connection design. Rather, you can use your custom template for the connection design. This is the way we can customize a template and use that template for our connection design. If I go to DXF, you will also notice all the same information. By the way, this DXF is interactive, means these blue lines or this blue information, these are interactive. And if I want to check from where this 31.75 is coming, I can simply click on this one and it will be highlighted in my window. This DXF file that is generated in connection design, these are interactive. These not these white ones, rather the blue ones. So if I want to check, what is this? 152.4. If I click on this one, it will show you this is the pitch, center to center distance between spacing between the bolts. 2 into 76.2 comes the 152.4. If I want to check, what is this? A36 is the material, the plate, material of the plate that is used for this connection. If I want to check from this diagram, what is 316 means it's the welding. So this is interactive drawing file. You can save it as a DXF file as well. But anyway, the most important point here is that for this connection design, we are now using a custom connection template. And obviously, we can further modify it. If I want to modify, I can modify it from here. And this connection is designed as I have selected AISC, so it is designed as per AISC code. So that's why the design code is important, because we are going to use the AISC 36016 design code for this connection template. The loads are coming from whatever load we have specified there. These are the design checks, standard design checks that are performed. There is no change here. Only change here is that we are using custom information for our connection design. So here you can see the length is perfect. The maximum limit is 340, minimum limit is 170, the specified value is 215.9. All the checks are okay, so that's why the green light is there. This is the way we can create a custom connection template with predefined data and use that for design. If we want to create similar template with different configuration, like side plate connection with 3 or 4 number of bolts, we can follow same procedure. There is another way to create multiple templates easily using copy paste option. We can even export the connector information to Excel, which can be used for reporting or drafting purpose. I'll cover this in the next video. Stay tuned.